Hello guys, welcome back to Malik034 channel. This is Mallikarjun. This is the continuous session for my ASM course, where in our previous session we saw about introduction about ASM, and then we saw software stack with and without ASM, and mirroring, striping, and benefits or advantages of ASM, and dynamic rebalancing, and ASM tools. And in this today's session, we are going to see about ASM architecture. So before I start with ASM architecture, if you are new to my channel, always go back to YouTube and search for Malik034, and then please do subscribe. If you like my videos, always please share, like, and comment. Let's start with the ASM architecture. Okay, so the ASM instance, if you see this screen, this particular screen talk about typical like complete overview of my ASM instance, and how it will communicate with my database instance. If you see, this is my database instance, database on ASM, and I have my database alert log at my database server, and this is entire thing is going to be my ASM instance, and that ASM instance, that ASM instance will communicate with my database instance. You can see this bidirectional operation here, and there is a CSS, cluster synchronization service, which will communicate, which will listen communication from both database end and ASM end, and then keep in sync. And then my particular ASM instance has its own ASM alert log, and this ASM will communicate with my I can say my storage layer, that is my storage disks, via disk groups. And again, once this database connection is established to my storage, and my database instance can directly talk to my storage instances, my storage disks or storage layers, right? This is typically about ASM instance, and in a single node instance, in case of if you are using Oracle restart service. And if you go with the rack, there will be multiple database nodes and multiple instances, and which will communicate to my disk groups. So this going I'm going to give you correlation. If you are using ASM, okay, so if you are using ASM, you can use your ASM as a CRS, or you can use your ASM as a HAS. What is CRS? CRS is cluster ready service in case of rack, and HAS, high availability service, in case of your Oracle restart, right? So both are like CRS and HAS will be triggered, with the help of OHSD, I can say, Oracle OHASD, Oracle High Availability Service Demand. And similarly, in case of HAS also, Oracle High Availability Service Demand will comes into picture. So this I'm going to give you once again in the correlation. So if I can say, if I can say, this is my traditional server, standalone server, and if I have my rack server here, okay, if I can say, this is my DB1, and this is going to be my DB2. Okay, so I'll just give the name. Okay, I'll give, sorry, this is my DB2, and again this is my DB2, and this is my DB2, right? So it's the same database, but I have three instances. I can give naming convention here as instance 1 and instance 2, and this is instance 3, right? And then what happens, like, if I have only one ASM, I can install this ASM server on the same DB server or on the separate server. I can say this as my ASM here. I can say ASM. And similarly, if I want to install my ASM on Rack database, I can install my ASM on the same server or on the different server. I mean, say, you can install on the same storage, or you can install on the different storage, the binaries I'm talking about. So as of now, I can say that I'm going to install on the same server. I can say this is going to be my ASM1, and this is going to be my ASM2, and this is going to be my ASM3. These are like ASM instances which will be managing my database instances. So, and then similarly, if I have my storage disk here, right, and similarly if I have my storage disk here, And then if I want to stripe this one as a Rico, I can say that Rico. Okay, this is Rico and this is the data, and I can say one more is control. Right, similarly I can type this one also, Rico and data, Rico and data, and sorry for that, Rico data, and one more control. Right, so I can just give you naming convention. This is Rico and this is data and this is my control. These are my three descriptions. Similarly here also, this is Rico and this is data and this is control. Right, so this is going to be a standalone server, and this is going to be my rack server. So what happened, in the standalone server I will be having my ASM instance and I'll be having my DB1 instance. So whatever the IO request for this database, it will go to ASM, and ASM will connect that IO request to my ASM disk groups, or basically the storage server. And then this particular database will directly start communicating with my storage disk, and all the IO operation will be directly redirected to my storage disk. But in the backend, ASM will be handling that IO requests. And similarly, if I have three database instances in case of rack, all this IO request will go to that particular ASM instance. Instance 1 of DB2, instance 2 of DB2, and instance 3 of DB2. All this IO request will goes to those particular ASM instance, and that ASM instance will pass the connection to my storage server, and then that particular instance will directly talk to my storage server, and at the backend ASM will be handling those IO requests. So in the restart service, this ASM will act as a Oracle restart. In the standalone, we can call it as a restart service. And whereas in the rack concept, this ASM instance, we can call it as a CRS, cluster ready services. And then what is the advantage of Oracle restart service? Whenever your instance crashes or instance goes down, your ASM instance will automatically restart this particular ASM database instance. You no need to start this particular database instance, because this I can say server A, and if this server A crashes because of some memory issue or some network issue, or this database will go down, and automatically when this server comes back online, Oracle ASM will keep checking this particular ASM instance, and if this ASM instance is not up, and then it will start the database instances. That is why we can call it as a Oracle restart service. And where it is in CRS, cluster synchronization service, and similarly same thing, like this I can say server X, and this is server Y, and this is my server Z. Okay, server Z. And in case of server X goes down, and this ASM1 instance will be keep checking this particular instance, and then if this particular instance is not available, and it will wait, and once the server is back online, automatically this ASM instance, this database instance will be back online. Similarly, this ASM instance 2 will be managing this particular database instance, and similarly this ASM3 instance will be managing this particular ASM instance. Whenever this server comes back online, automatically this your database instance will be brought online. That is cluster synchronization service. And along with that, it will manage all the ASM instance. If this instance is written some new data, and if the request comes from instance 2 or instance 3, and data will be transferred from instance 1 to the instance 2 or instance 3, the whatever new data available in the buffer cache. So everything will be managed by ASM. So that is in case of rack. So there are so many features or benefits. I will cover it in detail when I go through a rack concept and all, along with the ASM. So just now you can understand, in the restart service, and in the standalone server, it is going to be restart service, and in the cluster racks environment, it is going to be CRS. So that is what I wanted to cover it here. and this is going to be my typical architecture as I explained just now. And then if I go with the generic architecture, as I already covered just now here with the rack architecture, this concept, and if you correlate with this generic architecture, I have node 1 and I have node 2, and I have a db instance 1 and db instance 2 here, and I can see db writer which will write my database IO to my disk groups or actual disks, and I'll be having my ASM instance, and ASM instance will be managing my database connection. And you can see this one, ASMMB is basically helps for my database instance to look into my SP file which resides in my ASM disk group. And I'll be having a fail group FG, and RBEL is the rebalance. Whenever, as I said, whenever there's a new disk added or a new disk added or new disk or disk dropped from the disk group, the data will be dynamically shifted to the new disk, or data will be shifted back from the dropped disk to the existing disk. That will be done using RBEL rebalance process, and I'll be having a child process RBEL 0, 1, 2, 3, a number of RBEL process, and that will increase my rebalancing speed. And I'll be having my ASM disk, and on top of ASM disk I'll be creating my ASM disk groups. You can see this is a ASM disk group Tom and ASM disk group Dick and ASM disk group Harry. So I'll be having number of, I can create a number of disk groups, and then all this group will be accessed by my database instances. This is overall generic typical architecture, how ASM and then DB instance will communicate with my disk groups and disks, and then what are the background processes will be involved. So the ASM based components are like ASM instance, as I told. If you can see, the ASM instance are my base components, one of my base component, and storage devices disks. I can say disk 1, disk 2, and disk 3. Three disks are going to be my base component, and on top of disk, I'm going to create my record disk groups or data disk group, or control file disk group, or whatever disk group name you can give it, right? And inter instance communication service, CSS, as I told, uh, this instance 1 and instance 2 will communicate using CSS, and instance 2 and instance 3 will communicate using CSS, and instance 2 and instance 3 will communicate using CSS. I can give name as CSS, cluster synchronization service, cluster synchronization service, and this is also CSS. So as I told, like I have a table, I can say employee table here, employee T1, I have employee table, employee T1 I have here. This looks good. So I have employee table T1, I have ID 100, and then current salary is I can say 10 rupees, and then I can update that salary to 20 rupees, just for example. Okay, so, and there's a one more connection to the there's a new connection on instance 2 and instance 3. I have one user 1, user 2 here, and I have user 3 here. So if this user 2 is going to access same employee table 1 and user ID is 100, and you want to check what is the salary of that employee 100, employee ID 100, and then he will be getting a result as 20, the latest latest salary, whatever that's 100, this employee number 100 has 20, that you will be getting it here. And this one, this user 3 also query the same thing, and even he will get this 20, but this 20, the new updated value, is not written to my disks or my data. So it will be in my instance 1 buffer cache. Then how these user 2 and user 3 will get the latest data? For that, we'll be having something called interconnects. That we can in rack concept we can call it as a cache fusion, right? Whatever the latest data available in any of the instance buffer cache, that will be transferred to any one requested instances. So that is called cache fusion. So this 20 latest data will be transferred to instance 2 and instance 3, and then result will be displayed to the end user. So that is a one way of management that will be provided by my ASM instance, right? So, and instance intercommunication, CSS. So this instance 2 will be always try to communicate with instance 1, and instance 3 will be try to communicate with 1 and 2, and instance 1 will be communicating with instance 2 and 3, and then this instance 2 will be communicating with instance 1 and instance 3. At any cost in the cluster, all the instances will be communicating with each other with the help of CSS. So if in case any instance is not able to respond it back, so the node eviction is going to happen. So this is also going to be one of the base component in case of if you're working with the rack and ASM, and database on ASM. Finally, my database is going to reside on my ASM instances. So these are the 4 core component, and we will deep dive in detail about each of these. And then right now, I will cover Oracle instances quickly, as we all already aware of this ASM instances. We'll be having SGA, and then buffer cache, shared pool, redo log pool, Java pool, large pool. So many pools we'll be having in SGA, and then we'll be having a background processes. SMON, PMON, recoverer, and so many DB writer, log writer, all those background processes. And at the end we'll be having our actual data, that data files and control files and redo log files. This is typically normal traditional RDBMS or Oracle database instance architecture. And similarly, if you look into ASM instance architecture, you'll be having a SGA for ASM instance. As I'll go back, I'll be having my ASM instance, ASM1, ASM2, ASM3. In case of restart, I'll be having ASM. So I'll be having that ASM instance will be having my ASM instance will be having memory, and that memory will be having ASM cache. ASM cache is nothing but it will be divided into descriptor cache and metadata block cache. These are the two subcomponent in ASM cache, and they said pool and redo buffer cache. So similar thing if you can correlate with your traditional DBMS architecture. And this particular ASM will be having its own background processes, and this ASM has its only metadata. If you check your actual database, that actual database will be having your actual data, control file and redo log file. But whereas ASM instance will not be having any data, and it will be having only metadata. Right, this is about ASM instance architecture. And what is special about ASM instance? If you see, I'm talking about both RDBMS instance and ASM instance. But what is special about my ASM instance? The instance type is going to be ASM, right? Instance type is going to be ASM, and startup is going to be startup mount. My ASM instance will not go to open mode at any time, because this is not a database. This is going to be just a instance which can go maximum mount mode. Does not try to mount a database, but tries to mount a disk group. So if you set startup mount, it is not going to mount the database. It is going to mount the disk groups. Whatever the disk group defined in my ASM, those disk group is going to mount if you mount your ASM instance. So ASM underscore disk group is a parameter. You can find it out, your disk group details. And no open state for ASM. Alter database open will not work here, because it will go at the max mount state, because it is not a database, it's just instance. No user administrations, and cannot connect as a SYSDBA, because we cannot do any user administration here. You always connect as a SysASM only. This is special character about my ASM instance. So one of the other advantages using ASM instance is, in a single ASM storage you can have different RDBMS versions. As I given here my typical architecture, I have a disk group 1 and disk group 2 here, and then I'll be having my ASM architecture, ASM cluster where with 12.2, or you can go with the 12C, so 11.2 here. I can go with the 12C, or you can go with 18C or 19C, whatever latest version you can install your ASM instance, your clusterware, and you can host your n number of database versions. You can see 10.1, 10.2 and 11.2, and any version of database you can have different versions of database will be supported in my ASM instances. Right, so you can see this is dbhome1 db1, that is 10.1, dbhome2 db2, that is 10.2, dbhome3 db3, that is 11.2, and my ASM instance is 11.2, and then all will be running on different disk groups. So I will stop it here for today, and then I will cover three concept of my ASM instance, that is disk group and allocation unit and ASM files. And there's a few more interesting topics to cover, and we'll jump into our lab sessions and we'll see all this in details. Thank you guys.